Alrighty, so now we're going to be talking about quotient of a power, and we talked about, on the other side here, we were working with dividing exponents with the same base. So what we're going to be talking about is if we have a quotient to a power, and what you're going to find is we're going to rewrite this as multiplication, because any exponent can be rewritten as multiplication. So it means I would have x to the third over y times x to the third over y. So our new expression, and once again, if you want to pause this and try it yourself, that's always a good choice, and then check it. My new expression, when I do that, I'm like, oh, well, when I multiply those, that's x to the third times x to the third. Same base, and actually the same exponent as well, but that's like x to the third plus 3, which gives me x to the sixth. And on the bottom, I have y to the 1 times y to the 1, which is y to the 1 plus 1, which is y squared. So I can't do anything else with this because my bases are different. So I'm done with this. This is my finished expression. You'll see some problems later on where those bases are the same, and then you can reduce from there. But in this case, we cannot do that. They're on the same base. So what did you notice happen there, and will this always happen? Why or why not? I want you to take a second, pause, and try to answer that yourself. All right, so what I noticed was that the 2, it was like it was distributed to all the factors in the numerator and denominator. And feel free to pause and write that all down. I know that's a lot to write. So it's like I distributed that 2 to all terms in there. So I could have also thought about this as x to the third squared and then y squared. And we know when we raise a power to a power, we multiply those to find our answer. And this will always work because that exponent outside the parentheses tells you how many times to multiply each factor inside by itself. So when you're taking a quotient to a power, multiply the power or distribute the power to all the variables and numbers being inside the parentheses. So for instance, I have x to the third here. I'm sorry, x over 5 to the third, and that's like x divided by 5 to the third. So this would be like x over 5 times x over 5 times x over 5. There would be 1s there, so it would be like 1 plus 1 plus 1, which is x to the third. And on the bottom, it's like I have 5 to the 1 plus 1 plus 1, because there are 1s there that we just don't write. And so that's 5 to the third power. Now, if the exponent is reasonable like it is to the third, I could simplify that then to x to the third over 125. I could take it down to that point. I don't have to. I might not always need to if there's more going on in the problem where those might get canceled out later. But if I'm coming to the end of my problem and it's, like I said, it's a reasonable exponent, go ahead and do that. So this one, this is like x to the third times x to the third times x to the third times x to the third. And then each time, I'm not just getting the y, but I'm getting 4y. So there are 3 of those each. So when I say pass it out to everything inside, I mean everything inside. So that 4 is also going to get cubed. I'm sorry, not cubed, I was looking up there. It's going to get taken to the 4th power. So that means 4 to the 4th and y to the 4th. And then 3 plus 3 plus 3 plus 3 is going to give me x to the 12th. And once again, I could take that and I could find that x to the 4th, or 4 to the 4th power rather, would give me a decently reasonable number. So you could simplify that 4 to the 4th to 256, y to the 4th. Going on down here, I'm going to show these as straight distributive here. And then we're going to reduce. So I have x to the 5th times 3, and I have y to the 2nd times 3, over x squared times 3, and then remember that's to the 1st power. So I would get x to the 15, y to the 6th, over x to the 6th, y to the 3rd. Now what we learned earlier was that we can then reduce this. This becomes x to the 15 minus 6, and y to the 6 minus 3. So x to the 9th, y to the 3rd would be our final answer. You could have also reduced it over here and gotten x to the 5 minus 2, y to the 2 minus 1. And that would have all still been in there. And then when I distributed that, I would have gotten x to the 9th, y to the 3rd as well. So you can see we get the same answer. Once again, with this one, if I can reduce ahead of time, I can always do that before I square when I have actual numbers out there. So the 16 and the 4, well, that's going to reduce to just 4. So now I have 4b to the 5th, x to the 3rd, y to the 2nd. I'm like, oh, wait a minute, I could have taken out those b's. That would have become a 2 there. And then on the bottom, I just have a squared. So I've cleaned that one up a little bit then before I start passing out. So I'm going to have 4 squared, and that squared, and that squared, and that squared. Everything's going to be squared. So I have 4 squared, b to the 2nd squared, x to the 3rd squared, y to the 2nd squared, over a to the 2nd squared. So that's when I can end back up with 16, b to the 4th, x to the 6th, y to the 4th, a to the 4th. And like as always, if you feel comfortable going ahead and doing these by yourself and then going back and checking them, that's great too.